So, what do you think of this? Recently, astronomers were able to map about 1 billion stars around us. Sounds impressive, but that's less than 1% of the total stars in the Milky Way. It's statistically impossible for us to be the first intelligent species in the galaxy. There were advanced civilizations before us. There are some developing a way to communicate with us right now, and there will be more. The only question is, where is everybody? One thing you can't take away from human beings is our optimism and hope. All this time we've lived under the starry skies, a lot of people have looked up and thought we couldn't possibly be alone in the universe. And statistics tell us that we probably aren't. There are too many worlds out there, and life is too adaptable. In 2017, a group of British scientists discovered that life developed soon after the planet itself became habitable. We once thought that the development of life is a highly improbable event, but now this way of thinking is becoming obsolete. On the other hand, we've been looking for about 70 years for any sign of extraterrestrial life, or any communication from little green men or whatever they are, and we still have absolutely nothing to show for it. How is this possible? That exact question was once asked by famous Italian physicist Enrico Fermi, the creator of the first ever nuclear reactor. Since then, astronomers and ET enthusiasts alike have all become familiar with the Fermi paradox. In simple words, if there absolutely should be developed civilizations in the universe, then where is everybody? The Fermi paradox has a lot of potential solutions, about 75 to be precise, but today I'll focus on the major possible explanations for this troubling absence of aliens around us. The first group is all about two big ideas, the rare earth hypothesis and the idea of the Great Filter. They're closely related to each other, and both can be soul-crushing for those believers out there who want to meet extraterrestrials in person one day. So please, brace yourself. Can you imagine how much would have to fall into place for an advanced civilization to rise to our level, sending radio signals into space, launching huge telescopes and satellites, searching for exoplanets and other life? Starting with the qualities of the Sun, neighbor planets, the Earth itself and the Moon, and ending with our natural curiosity and aching need to reach out into space. Let's just say we hit a jackpot in all categories. These requirements combined are called the Great Filter, and the ability of our home planet to come through it all and win the biggest lottery in the universe is what the rare Earth hypothesis is all about. So, what filters are there, and what conditions would be good enough for our possible alien buddies to evolve and develop their civilization? Well, their sun must be something like our sun, not too bright or hot, so that whatever planets might orbit around don't fry to a crisp, but not too dim or cool, so they'd just be giant frozen cold spheres. The planet they live on should be in the habitable zone of their star. One thing to notice is that we've already found planets near our stars that are just like that. So at this point, all mentioned requirements of the Great Filter should be passable. The true difficulties start here. For example, there must be something like Jupiter around. Jupiter is hugely beneficial to us. Its mass attracts all the space debris, meteors, and comets like a giant vacuum cleaner. If not for it, the Earth would be bombarded with giant space rocks all the time. Another big thing that supports us is our Moon. Did you know that the Moon is the biggest natural satellite in the solar system in relation to the size of the planet it's orbiting? The Moon's size is a bit under 1/3 of the Earth's, and without a body like this in our orbit, the Earth would be unstable and unable to support life at all. The size of our planet and its speed of rotation make an optimal day and night cycle. Our planet has lots of chemical elements, crucial for the development of life. Most importantly, hydrogen, nitrogen, carbon, oxygen, sulfur, and phosphorus. The last one is quite rare in the galaxy overall, and originates only from supernova explosions, according to recent research from Cardiff University in Wales. And you think that makes up for a rare Earth? That's not even half of the factors, and we'll be here all day if we try to go through all of them. You get the idea. The Earth is an extremely rare planet indeed. More important even is that we're only halfway through the Great Filter too. Planets like Earth still must exist in the Milky Way. Let's imagine these planets developed life, but they still have to be able to support it long enough for evolution to get to work. From self-replicating organic molecules like DNA and RNA, to single-cell organisms, then to complex life with distinctive organs, then to a range of species that can adapt to different environments and inhabit the whole planet, and finally to an intelligent life form that can use tools, think, and communicate. That's a long, long road that takes at least 4 billion years. All kinds of stuff can happen through that period. Gamma-ray bursts flashing through the galaxy, extreme ultraviolet radiation, collisions with other celestial bodies. Only if all that misses the planet would we have a winner. Eventually, it'll have beings that look at the skies from time to time and think that they probably aren't alone in the universe. This is just how evolution works, always going for biological complication and the single most effective adaptation tools. And the tool that stands above all others is intelligence. But these intelligent folks still won't be the ultimate winners of this universal lottery. They still must develop technology to go into space and send signals. The development of technology is tough enough by itself, but it's not as tough as the development of a society that would allow them to live in peace and to aim for the stars. There's no way to calculate how often all of this could happen in the universe, but let's be clear, the probability isn't looking too good. So the Great Filter idea is a strong candidate to the solution of the Fermi paradox, though a bitter one. Another solution is far more optimistic. Aliens are out there, but we just can't communicate properly with them. What we use as a means of communication is mostly radio signals. But remember all the steps some abstract intelligent life form needs to go through to become an advanced technological civilization. What if they went through a significantly different route in technology, one that's not even comprehensible for us? What if they did so because their own communication is different than ours? Like through the release of pheromones and complex movements, like insects on Earth, or through a change of color, like octopuses and chameleons, or via smell markers like cats and dogs, for example. How strange would their high-distance communication technology be to us? We probably wouldn't even recognize it for what it is, just like they wouldn't recognize our signals as something intelligible. In this case, we would be basically invisible to each other, no matter how close we are on a galactic scale. Another argument is that they must already be communicating through more advanced technology between different colonies at this point. But look at this from another point. People still use mail to this date, even though we have the internet. Nothing stops aliens from receiving technologically outdated messages, and nothing stops them from locating where our radio-noisy planet is in the galaxy. But it still doesn't happen, so the Fermi paradox stands firm with its question. The next solution is far more possible. In basic terms, it proposes that we aren't alone, but we are the first to advance our civilization to the needed level of technology. It'll take an unimaginable amount of time for us to peek the first signals from ETs. This argument is even more believable because of how hard it is for life to find its place in the galaxy. Maybe we're at the start of the Milky Way, and we're the first to see it for ourselves. There's also a funny argument that aliens are so unlike humans in their way of thinking that they simply don't want to communicate with anyone else. Reasons for that could be many things. They might be just grumpy, too afraid of anything outside of their world. Or maybe they're able to fulfill all their needs on their home planet in Utopia, and simply don't want to explore further. Best leave it to sci-fi writers, but anyway, it's worth mentioning that such scenarios are possible, and they can be quite effective solutions to the Fermi paradox. And finally, the solutions all fans of UFOs want to believe in. They really are common in the galaxy, but they can hide from us, and maybe they're already around us. Ooh. They might be something we don't even recognize as aliens, or they're very good at mimicking us. Unfortunately, this argument is as interesting as your imagination allows it to be, because there aren't any objective restrictions for it. If they are this advanced, then these possibilities are endless. You know the joke about the chance of meeting aliens in any given day? It's exactly 50%. You either meet them or not. This is precisely what this argument means. And what do you think? What are our chances to find and meet aliens in the future? Let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend. But hey, don't go have lunch with ET just yet. We have over 2,000 cool videos for you to check out. All you need to do is pick the left or right video, click on it, and enjoy. Stay on the bright side of life.